Hello and welcome to Love Math. Today we will do the topic Polynomials Part 1. So these are the topics which we will be covering in this lecture. Polynomial definition, what does polynomial mean? Then degree of polynomial, types of polynomials, and solving a simple polynomial. So we start with the first topic, polynomial. What does it mean? So according to different math high school books, this is the definition which they provide. Let x be a variable, n be a positive integer, and as a1, a2, an be constants or real numbers, then polynomial f of x equals an x raised to the power n plus an minus 1 x raised to the power n minus 1 till a1x plus a0. It's confusing, right? So we will divide the particular definition to be easy to understand. So polynomial. As you can see, I have divided the word polynomial in two different words. Poly means many and nomial, which means names or mathematically terms. So polynomial is nothing but a combination or a summation of many terms. So what are these terms? Let's see. So this is the equation which we had given in the textbook. In many math high school book, it's the general form of a polynomial. So as you can see, the polynomial f of x is made of these four terms: an raised to x raised to n, an minus 1 x raised to n minus 1, a1x, and a0. So these four are the terms of the polynomial: term 1, term 2, term 3, and term 4. So these four terms, when combined or when added, makes up a polynomial, as the name suggests us. So, for an example, if we take a polynomial f of x equals 3x plus 2, so how many terms do we have in this polynomial? We have one 3x and second 2. So two terms 3x and 2 when combined forms a polynomial. So we have two terms. Okay, so now when we concentrate on the first term, an into x raised to n, that is the product of two different terms, different an and x raised to n, where an is the coefficient and x raised to n is a variable. Coefficient is just a fancy word for numbers or constants. So in the same example which we saw there, f of x equals 3x plus 2, we have two terms, 3x and 2. But if we see the first term, 3x, that is nothing but the product of 3 and x. So 3 and 2, yeah. So 3 is the coefficient and x is the variable. Okay, and second term 2, it just has a coefficient but no variable. So got it? Good. So now what makes a polynomial? Suppose we take this set of terms, 2x squared plus 2 squared root of x plus 5. Now you can say that this also is a collection of three different terms: 2x squared, 2 under 2 square root of x, and 5. But is that really a polynomial? No, because now consider this equation again. I will refer to this equation all throughout this chapter, so please get familiar to it. So in this equation, in this polynomial, n should be a positive real integer. You know what a real number is like. Real number ranges from minus infinity to plus infinity. All the numbers between those are real numbers. But in this polynomial, n should be a positive, that is more than 0, and it should be an integer. In our case, in our polynomial, we have a term on square root of x. A square root of x is x raised to half or x raised to 0.5. But 0.5 is positive, but it is not an integer. So we can say that 2x squared plus 2 square root of x plus 5 is not a polynomial because the power of x 0.5 is not an integer. So this is not a polynomial. Okay, now next is the degree of polynomial. So according to the math high school books, this is the general form of the polynomial, and this is the definition. The exponent of the highest degree term in the polynomial is known as its degree. Confusing, right? Math textbooks are always confusing. So now let's look at another way. Suppose we consider a polynomial as 7 f of x equals 7x raised to 4 plus 5x cubed negative minus 8x squared plus 3x plus 9. All right. Now, as we did, tell me there are how many terms in this equation, right? So we have 7x raised to 4, we have 5x cubed, we have negative 8x squared, we have 3x and 9. So there are 5 terms that make up this polynomial. Now, if you observe nicely, you can see that each term is supported with a variable x which is powered to some real integer, except 9. 9 is a constant. So, if we see the first term 7x raised to 4, the x is raised to a positive real integer 4. Next, 5x cubed, the power is 3, negative 8x squared has 2, 3x has 1. Now what about 9? 9 has no variable. Actually it has. 9 is when multiplied by x raised to the power 0 gives you 9, because any number raised to the power 0 is 1 and 9 multiplied by 1 is 9. So here in this polynomial containing 5 terms, we have 5 different powers: 4, 3, 2, 1 and 0. And if you see, the number 4 is greatest of all the powers. So therefore we conclude that the degree of the polynomial is the greatest power, the greatest degree term in the polynomial. As you can see, the greatest power is 4. So the degree of polynomial f of x is 4. Let's do another example. Let's take the polynomial g of x equals 6x minus 5. Here I have taken g of x instead of f of x because we already have taken that in the previous example. So here we have two terms, right? We have 6x and we have negative 5 that make up a polynomial. So now 6x has a variable x with a power 1 and negative 5 has a variable x with a power 0. So as you see, 1 is more than 0. 1 is the greatest power of the entire polynomial. So therefore, the degree of polynomial g of x is equals 1. Got it? Good. Next topic is the types of polynomial. Now, I have made this type of polynomial based on the degree of polynomial. As we saw in the previous slide, that there were two different degrees of polynomials. Once it was 4 and then it was 1, right? So now let's see polynomial. The first type is a constant polynomial. So as the name suggests, the constant polynomial is a polynomial having a degree 0. For example, f of x equals 4. Now 4 has a variable x raised to the power 0. So, so it has only one power. So it has to be the degree of polynomial. And as you can see, the 4, the f of x equals 4, that is independent of any input x. So whatever input I take instead of x, I will always get an answer 4 that is constant. So the name constant polynomial. The second is the linear polynomial. Linear polynomial is the polynomial with a degree 1. Alright. Example is f of x equals 4x plus 1. So here you can see there are two terms, 4x and 1, that make up a polynomial. You can see the first term, 4x, is raised to the power 1, and the second term is raised to the power 0. So the degree of this polynomial is 1, being a linear polynomial. Third type is a quadratic polynomial. You will do this a lot in this chapter, so make sure you know this. So quadratic polynomial is a polynomial with degree 2. For example, f of x equals 4x squared plus 3x plus 1. You can see there are three terms, 4x squared, 3x and 1, that make up this polynomial. 4x squared has a variable x with the power 2, 3x has a variable x with the power 1, and 1 has a variable x with the power 0. So you can see 2 is the highest power in the entire polynomial. So the degree of polynomial is 2, being a quadratic polynomial. The next one is a cubic polynomial. The cubic polynomial is a polynomial with a degree 3. For example, f of x equals 4x cubed plus 3x squared plus 2x plus 1. In this polynomial, we see that there are four terms in it: 4x cubed, 3x squared, 2x, and 1. The first term, 4x cubed, has a power 3. The second term has a power 2. The third term, 2x, has power 1. And the last term, 1, is multiplied by x raised to the power 0. So it is 0. So you can see the maximum power of the variable x is 3. So the degree of this polynomial is 3, hence being a cubic polynomial. Next is biquadratic polynomial. This you won't see much in this chapter, so it's fine. Biquadratic polynomial is a polynomial with a degree 4. Okay. For example, f of x equals 4x to the power 4 plus 3x squared plus 2x plus 1. Now some of you will, think that why isn't any x cube factor in this equation? Well, it is not necessary that it should have an x cube in this equation, because if you consider this as ax and ax raised to n with a coefficient of 0, that entire term will be 0. All right. So now, this is a summary of what we did in the types of polynomials. It's a table. On the left hand side of the table, we have the degree of polynomial, and on the right hand side of the table, we have the type of polynomial. So with degree from 0 to 4, we have different types of polynomial: constant, linear, quadratic, cubic, and biquadratic. Easy. Let's go ahead. So this is the last topic of this lecture, and very important: solving a polynomial. What does solving a polynomial really mean? All right. So the definition goes like this: if f of x is a polynomial and alpha is any real number, then the real number obtained by replacing x by alpha in f of x is called value of f of x at x equals alpha, and is denoted by f of alpha. Extremely confusing. Let's break it down. So the first line reads, if f of x is a polynomial and alpha is a real number. So let's assume any. F of x, a polynomial, fx raised to 4 plus 3x squared plus 2x plus 1, and alpha is any real number 2. Okay, then read the next sentence. Then the real number obtained by replacing x by alpha. We have alpha of 2. So the real number obtained by replacing x by 2 in f of x is called the value of f of x at x equals 2. So replace x with alpha in the given polynomial. So let's do it. So we'll get a function of x will be function of alpha if we replace that function with alpha. Okay, so f of x becomes f of alpha, alpha being 2, it becomes f of 2, and then replace x with 2. So 4x raised to 4 becomes 4 into 2 raised to 4, 3x squared becomes 3 into 2 square, 2x becomes 2 into 2, and 1 has no variable, so it remains 1. And just do the math, solve the right hand side of the equation, and you'll get your answer. So f of 2 being 81 is I solved this polynomial at x equals 2. So what we did today was we defined a polynomial, what a polynomial is, and what makes a polynomial, like n should be a real positive integer always. Then we did the degree of polynomial, like what is the highest power to the x will be the degree of that polynomial. Then we did the different types of polynomial according to the degrees, like constant polynomial, linear polynomial, quadratic polynomial, cubic polynomial, and biquadratic polynomial. Then at last we did solving a polynomial, where we solve by replacing x with any given value and then doing the math. Alright, now in the next lectures we'll be doing the zeros of a polynomial, and we will be graphing a linear, quadratic, and a cubic polynomial. It will be really exciting lecture. Thank you so much, and see you then.